Hey everyone, this is Mayur. Welcome to ML Works. In this video, we'll talk about Dask Bag, which is a module in Dask which helps you to implement functionalities like mapping, filtering by, or group by operations, or fold by operations, which are typically found in Pandas library. We try to replicate the same thing in Dask. The only difference is in Pandas, what we see is when we apply these functions like mapping or filter by operations or group by operations, these things happen sequentially. Okay, so in Dask, what it does is it uses distributed computing to segregate the task into over multiple workers at the same time utilizing the course of your system efficiently. Okay, that's when DAS comes into picture. The advantages of DAS comes into picture. So in this video, what we'll do in this notebook is we'll try to understand the basic functionalities of Dask Bag, how it tries to move part of the job in particular course or particular workers, and how it does it quickly. Okay, so we'll try to understand that part. Okay, first what we'll do is we have a Dask client created, which will help us to view the workers on the Dask cluster. So once we run this, we'll get the cluster information and the dashboard. Okay, and here you will notice all the bytes that is occupied by the on workers, and we'll have this workers here where we have four workers running, and across which we have same amount of compute allocated, and we can see other background utilization that is happening. Okay, so across the workers that we can capture here, and any of the task which is running on task can be viewed on the profile or graph. Okay, when you start running the tasks. Okay, so let's get started with Dask Bag here. Okay, what we'll do is first we'll download a data set which will be segregated as 10 partition. Okay, and each of this partition can be stored as a separate JSON file. And if you want to perform some operations on those JSON, you will parallelly load all the files and perform some operations parallelly, and then you will save it across in some other folders. So first step is we just create a folder called as data, and then we download a data set here. Make people is nothing but it is a data set with around it is a data set around what details of the person and his credit card and its address. So this is generated in the backend using something called as mimes library. This is a fake data generator library. Okay, so in the backend it uses that. So once that is done, we'll see here B, which is nothing but bag. Okay, dash.bag. It uses this library, and the data set is segregated across 10 partition. Now this B is again, we are using map functionality, and we map a function called as json.dumps on this data set such that we convert that data set into a JSON files using .to text files. Okay, and we encode that particular data set. So this will create 10 files inside data folder. Okay, and it will be like starting from 0 to 9. Okay, the folder file name. So if we see here, there will be 0.json, 1.json until 9.json. Now we'll look into one of those JSON files. We'll do hit of 2. So what it contains? It contains age, name of the person, occupation, telephone number, address, expiration date, credit card information, and its expiration. So we looked at two data, and we created 10 JSON files stored in particular folder. Now what we'll do is again we'll map a particular function. In this case, json.loads. We'll map that function to read the text from those JSON files. Here, the JSON file is not a single file, a bunch of files that is 0 to 9. Okay, we'll load that into B. So we have loaded that, and now it is still in the backend. It is doing lazy evaluation. It means that it has not yet loaded unless you do something called as b.take of 2. Okay, or take of 5 or take of 10. Okay, till then it will be in what, in a lazy evaluation mode. Unless you don't perform dot take or dot compute in Dask, it won't do any actions. Okay, so here it will load two records, 65 and 25, age 25. These are two records. That is JSON objects that has been picked from the B object. Now, what we'll do is we'll try to filter records of the 10 files we have loaded. Okay, of the 10 files we have loaded, we want to perform some kind of operations. Like for example, there is b dot filter. We apply a lambda function record colon record of age greater than 50, and we want to take only two people. Okay, people with age greater than 50, and we want to show two people alone. So when we do that, we'll see here 65. Daryl Wolf, blacksmith, age is 65. And since we are looking for age greater than 50, we'll have 51. This is another record which has been filtered from 10 JSON files. It went through all the 10 JSON files. It took randomly two particular records. Now this is filter, okay, where we apply lambda function and pick two files. Next we map and then apply lambda function and take randomly two records with the just to get the occupation details of two records. So this is again, it is taking directly, it is showing the occupation blacksmith and letting agent. Okay. Now what we'll do is we'll perform some kind of mathematical operation which is like dot count, and here we did dot take, okay, to view two records. Now what we'll do is b dot count dot compute. Okay, it will show the total number of records overall present. There are 10,000 records present in total. Now these all these operations which we saw earlier, okay, we have one filter, okay, one map, then we have one count. Now what we do is we combine all these functionalities, map, filter, okay, all these as a chain of operations. Okay, first what it will do in this particular sample, if you see, first it will do p dot filter, okay, age greater than 30 records, okay, and then we map, okay, so we get the details of the occupation. Then we sort the whole records with the frequency sorted in a frequency sorted manner, and then we also take only the top 10 records. Okay, so here we'll do this, and it has done nothing. Actually, it is in lazy evaluation mode right now. Okay, once you apply dot compute, it will fetch you the results. So what it shows, it is the occupation with the age greater than 30, okay, and the number of people with that particular occupation. That is 15 number of 15 people have this particular occupation, 15 people have this particular occupation, and in such a manner. Yep. So this is how we create a map or chain of functions here: filter, map, frequency, stop, k. Now, similarly, we can do this thing here, okay, where you are fetching the records greater than 30 of records with age greater than 30, and a map a function called json.dumps, okay, and fetch all those records and stored it into another folder, okay, which is a processed data we get. So this is data processed dot 10 until 9 we have. Okay, since we have 10 buckets of records, we get 10 processed bunch of records. Okay, so we can look into that. So we have this data, though we have here JSON, and here if you look at all the records will have age greater than 30. Okay, and is there any other condition we have brought? So we have just put the condition as 30, and we got all the records here from each of those buckets. Okay, so this is how we can apply what you call all these kind of complex queries you can create. Okay, which can be used across by utilizing all the cores in your system and do it quickly. Because if you want to do this particular operations like what one JSON file, if you want to pick it up and then you want to perform filter operation and then load the second file, you have to iterate through a for loop. Okay, all these things will happen when you do it using pandas. Okay, so with Dask.bag, we can simultaneously load all the 10 files. We can perform all the operations simultaneously and store the processed data in separate folder. All things happening at the same time. Okay, this will automatically reduce the time taken to perform processing. Okay, so I hope you got all the points that I'm trying to convey here. Okay, how we can apply map, filter, and how we can map the functions on particular data set, how the compute will happen when you do dot take two, take off two, or dot compute, how we can chain the bunch of operations together. So What I'll do is I'll share this notebook in my GitHub repository. You can take a look at it, try to understand Dask because I have done already. I have done bunch of notebooks I have. Okay, where I'm showcasing Dask.delayed, Dask basics. I have task distributed, Dask delayed group by. So bunch of notebooks are already present. This will help you to understand how you can apply Dask for distributed computing in Python. Okay. With this, I'll be concluding this particular video. Thank you so much.